In this video, I'm going to cover how to construct, edit, and copy an Excel formula. Let me begin with a very simple formula to add two digits, 5 and 3. For the purpose of illustration, let me select an empty cell. In Excel, every formula should start with an equal sign. So I'm going to enter an equal sign. Then I will enter the digit 5, then the operator plus icon, and then the second digit 3. Finally, I'm going to press enter to input the formula in Excel. You can see the result 8. Please notice that the cell displays the formula result and not the formula that I just entered. If I want to see the formula, then I have to look here in the formula bar. Now, let me explain how to edit the formula. There are two ways to edit a formula. One is a formula bar and the other is the F2 key. You can see that I can view and edit the formula in the cell itself. Now, I'm going to show you an altogether different method for constructing a formula. This is very important and potentially this will change the way you view the Excel software. As you notice, I have used the digits 5 and 3 in the formula. Now, I'm going to store them in cells. I will enter 5 in cell B1 and 3 in the cell B2. And then, in cell C1, I'm going to enter the formula. I will start with the equal sign just like the previous formula. But instead of entering 5, I'm going to select the cell B1, which contains the digit 5. You can see this marquee here. That means the cell is selected in the formula. I'm going to enter the operator plus, just as before. But instead of entering 3, I'm going to select the cell B2, which contains the digit 3. You can see this marquee here. That means the cell is selected in the formula. And then press enter. Now, you can see the formula result, which is the same as the one we got before. As you advance in Excel, you will realize the benefit of cell referencing. It offers you the flexibility to change the values stored in cells A1 and B1 at will, and Excel computes the result without changing the formula. I will show you how that works. Let me change the value in B1 from 5 to 10 and then press enter. You can see that Excel has computed a new result as soon as I press enter. Now, I will show you how to read the formulas that have cell references. You can see that in the formula, cell references have color codes. Here, the cell reference for B1 is highlighted in blue, whereas the cell reference in B2 is in red. You can see that the rectangular borders of the cells B1 and B2 have matching color codes. Formula reading means identifying the input cells by matching color codes. Next, I'm going to show you how to edit cell references in the formula. There are two ways to edit cell references in the formula. Let's begin with editing with typing. For the purpose of illustrating, consider replacing cell reference B2 with the cell reference B3. For this, I have to select the cell containing the formula. Press F2 or double-click and go to cell reference B2 and then type 3 in place of 2. Finally, press enter. I don't recommend you use this method. Let me show you the other method which I will recommend. Let me press undo so that I can go back to the original formula. Now the second method is editing by clicking and dragging the input cells. For this, I'm going to select the cell containing the formula. And I click either F2 or double-click the cell. You can see the color code on the input cells and the matching color codes on the references is in the formula. Now I'm going to select the cell reference and click the mouse and drag it onto the next cell. Now you can see that the cell reference in the formula has changed. Then press enter and you can see the result. The final topic is copying the formula. Towards the end of this topic, you will understand that in Excel, copying text and copying formulas are different. For the purpose of illustration, let me consider a very simple formula. I'm going to select a cell and let's call this as the source cell and enter equals B1. Now I'm going to press Ctrl and C simultaneously. Then I am moving to F9, which is my destination cell, and press Ctrl and V simultaneously. You can see that the formula is copied, but the cell reference in the formula has changed from B1 to E1. Copying a formula text is an important concept. Let me show you this. Select the source cell, press F2, select the entire formula, press Ctrl C simultaneously. I'm going to paste the formula in the destination cell. You can see that the cell reference has remained the same. So, unlike copying text, When formulas are copied from source to destination, the cell reference changes. This is because, in case formula, we are really not copying the formula. Instead, we are copying the relationships implied in the formula. This means what is B1 to the source cell is E1 to the destination cell. There are three methods in which we can refer to a cell in an Excel formula. We can refer to a cell either as a relative reference or absolute reference, or mixed, which means part relative and part absolute. These references behave differently when the formula is copied from one cell to another. In this video, we're going to explain the behavior of relative cell references. Let me begin with the relative referencing method. For the sake of illustration, I'm going to enter a formula equals B1 in C32, which I call the source cell. Now, I'm going to copy the formula and paste it on F34, which I will call the destination cell. Let me methodically state the argument. Cell B1 contains the value 10. Therefore, B1 should be equal to 10. F34 is a copy of C32. Should its value also be 10? The answer is no, because the copy of the formula is not like the copy of the text. When a formula is copied, we're not copying the characters such as C, 3, 2, and equals, etc., etc. Instead, we are copying the relationship represented in that formula. Now, let me explain the nature of relationship represented in an Excel formula. Let me do this with the help of a grid. The source cell is C32. It is at the intersection of the third column and the 32nd row. The destination cell is F34, and it is at the intersection of the 6th column and the 34th row. The cell referred in the formula is B1, and it is at the intersection of the 2nd column and the 1st row. Now, let me focus on the relationship. The value in the 3rd column and the 32nd row is dependent on the value stored in the 2nd column and the 1st row. For making this sound simple, let me restate this. The 3rd column and the 32nd row is dependent on the 2nd column and the 1st row. The question is, the 6th column and the 34th row should depend on which column and which row. The destination formula has E3 in place of B1. Now, let me explain why E3 and why not any other cell reference. First, let us look at the change in the formula from the source to the destination. The formula has moved from the 32nd row to the 34th row. Therefore, the B1 cell reference located in the first row should also move by 2 rows. The new row reference should be 3. The formula has moved from the 3rd column to the 6th column. Therefore, the B1 cell reference located in the 2nd column should also move by 3 columns. The new column reference should be 5. Therefore, the destination formula row reference is 5 and the column reference is E. In other words, the cell reference in the destination cell formula should be E5. Let us generalize this principle. The change cell references contained in cell formula should be relative to the change in the location of the formula itself. This is the principle behind the relative referencing system. Let me explain this principle by conditioning source and destination relationships. First, copying formula down in the same column, I'm going to copy the same formula from C32 to C35. Now, let me explain once again with the help of this grid. The source cell row reference is 32. Destination cell row reference is 35. The row reference has increased by 3. The source cell column reference is C. The destination cell column reference is also C. There's no change in the column reference. Therefore, the cell reference B1 should change to B4. And you can see the new cell reference is B4. When a formula is copied down the same column, the row references change, but the column references do not change. Second, copying formula across in the same row. I'm going to copy the same formula from C32 to E32. Now, let me explain once again with the help of this grid. The source cell row reference is 32. The destination cell row reference is 32. There's no change in the row reference. The source cell column reference is C, but the destination cell column reference is E. The column reference is increased by 2. Therefore, the cell reference B1 should change to D1. And you can see that the new cell reference is D1. When a formula is copied across the same row, the column references change, but the row references do not change. In this video, I'm going to cover absolute cell reference and how they behave when the formula is copied from one cell to the other. The process of changing a relative reference into an absolute cell reference is called fixing. Fixing means not moving, stationary, constant, or not changing. Therefore, fixed references, by definition, don't change when moved from one location to the other. Let me show you absolute reference with an example. In this formula, $B$1 is an absolute reference. Now, compare this with the relative reference formula. You can see a $ added before the column reference and a $ added before the row reference. The dollar symbol denotes anchoring. Anchoring means not moving. Now, let us discuss the behavior of absolute references when formula is copied from one cell to the other. For the purpose of illustration, let me enter the number 10 in cell B1. And I'm going to enter a simple formula equals $B$1 in cell C32. Now, I'm going to copy this formula from C32 to F34. You can see that the formula remains the same. And when I copy from here to cell E32, the formula will not change. Let me prove this point beyond any doubt. I'm going to copy to cell C35. You can see the formula remains the same. Now we can generalize this principle. Relative cell references change when the formula containing them is copied from one cell to the other, whereas absolute cell references do not change when the formula containing them is copied from one cell to the other. Now, let us look at a formula that is both a relative reference and a fixed reference. Let me enter equals $B$1 plus B1 in cell C32. And let me copy this to cell F34. What do you expect the formula in F34 to look like? We expect $B$1 to remain the same as it is in absolute reference. We expect B1 to change to E3. You can see that the formula in F34 is equals $B$1 plus E3. Here, let me make an important point. You can see here that the same cell is referred to in a relative manner in one place and an absolute manner in another place. This means the cell B1 is neither absolute nor relative. It can be either of the two based on how we refer to it in the formula. In this video, I'm going to show a real-world application of operators and their usage in Excel. Let me take up the example of computing the cost of a parcel. The total cost of the parcel is its packaging charges plus the delivery charges. The packaging charge is 500 cents per parcel. The delivery charges are 95 cents per kilograms of parcel weight. And the total cost has to be computed in dollar terms. Now let me give it a try. I'm going to enter 10 in cell D15, 500 in cell D16, and 95 in cell D17. I'm going to type the formula equals D15 times D17 plus D16 and press enter. Excel returns the answer 1,450. The answer is correct, but it is in cents and not dollars. So let me add divide by 100 at the end. You can see that the formula equals D15 times D17 plus D16 divided by 100. Press enter and Excel returns the answer as 955. But the answer is wrong. I will show you how Excel arrived at 955. Excel does it in 3 steps. In step 1, Excel will multiply 10 and 95 and will store the result as 950. In step 2, Excel will divide 500 by 100 and will store the result as 5. In step 3, Excel will add 950 and 5 and will return the answer as 955. We expected the sequence to be multiply, add, divide, but Excel has followed the multiply, divide, add sequence. In other words, Excel did not understand our requirement. If our expectation is to compute certain parts of the formula first, then we should put that part within the parentheses. Let me open a parentheses at the beginning and then close it before the division. You can see the formula equals open parentheses D15 times D17 plus D16 close parentheses divided by 100. I press enter and I get 14.5, which is the correct answer. I will show you how Excel arrived at 14.5. In this case, Excel does it in 2 steps. In step 1, Excel will solve the part within the parentheses. It computes 950 plus 500 equals 1450. In step 2, Excel will divide 1450 by 100 and it will return 14.5. Let me deviate a bit and show you something else. While a parentheses lets us tell Excel to solve the formula in a particular way, it could be a pain. In order to illustrate this point, let me remove the closed parentheses and press enter. Excel will prompt warning that the formula has a typo. and additionally, it recommends a closing parentheses. Sometimes Excel recommends closing parentheses in the right place, but not always. In this case, it is recommending in the wrong place, so we are going to select the No option. Now, Excel will prompt a warning that the formula is missing an opening or closing parentheses. The location of opening and closing parentheses is very important. If you insert parentheses in the wrong location, the answer will be wrong. So closing parentheses anywhere will not solve the problem. Closing parentheses in the right place will solve the problem. Operators define relationships between two variables in an Excel formula. There are four types of operators. They're arithmetic operators, logical operators, text operators, and reference operators. In this video, I'm going to cover arithmetic operators. Others will be covered later. Arithmetic operators are addition, subtraction, multiplication, division, exponential. A single Excel formula can have multiple operators. However, while executing the formula, Excel solves operators one after the other. Excel does not execute operators in the same sequence that they are present in the formula. It follows its own method to decide which one to solve first and which ones to solve last. It follows a priority pattern, which I'm going to explain now. The first priority is given to parentheses. The second priority is to exponential. The third priority is for both multiplication and division. And the last priority is for addition and subtraction. When two operators enjoy the same priority, Excel executes them whichever comes first when reading them from left to right. Let me explain this left to right principle with examples. First, I will take up division and multiplication operators which have the same priority. Let's consider a formula equals 4 divided by 4 multiplied by 3. How should Excel solve this formula? Should Excel multiply 4 and 3 first, or should Excel divide 4 by 4 first? If Excel multiplies first, then the final result will be 1/3. If Excel divides first, then the final result will be 3. Let's ask Excel how it resolves. I'm going to enter the formula equals 4 divided by 4 times 3 and press enter. You can see that the answer is 3. This means Excel has done division first and then the multiplication. It is because of the left to right rule. Some of you might not be very clear on the calculation part. Let me explain that again. Excel solves this formula in two steps. In step 1, Excel will divide 4 by 4 and temporarily store the result as 1. In step 2, Excel will multiply that result with 3 and returns 3 as the final answer. Next is sequencing addition and subtraction operators that enjoy the same priority. Let us consider a formula 6 minus 4 plus 2. Once again, should Excel add 4 and 2 first, or should Excel subtract 4 from 6 first? If Excel adds first, then the final result will be 0. If Excel subtracts first, then the final result will be 4. Let's see how Excel solves this formula. I'm going to enter the formula and press enter. As you can see, the answer is 4. This is because Excel follows the left to right rule. Let me explain the calculation once again. Excel solves this formula in two steps. In step 1, Excel will subtract 4 from 6 and temporarily store the result as 2. In step 2, Excel will add that result with 2 and returns the answer as 4.